For
This
me,
conference will
I
now
have
be
other
recorded.
engagements before 8 o'clock, so sometimes it might be little late. But later, from after first week, maybe after 10 days, we're going to move to 7 a.m. to 8 a.m. IST time, and it should be more refined. Okay. All right. So thank you all for joining. Just give me a second. I'll start my sharing my screen. Mm, mm, mm. All right. Welcome and thank you for joining. So we'll before we start, I would like to kind of welcome you and set up some ground rules on our on our classes. Okay. So before we begin, I want to just talk about a few things. As I said, I mean, for those who did not join the demo, our course might take anywhere between 10 to 12 weeks. Okay, and based on the breaks that might have, I mean, that I might take, it might slightly extend, but mostly I'll try to complete by 10 weeks. And again, my idea is to drive the concepts clearly to you and explain as much as possible rather than being time bound. Okay, so some ground rules, very very basic ground rules. I don't want to set up a lot of ground rules, but respect the speaker, meaning when I'm speaking, maybe wait for me to pause and then ask a question, or if someone else is asking a question, just be in mute and you know only unmute when you're not speaking. Just, I mean, we are because too much of digital life, we sometimes are unaware of the fact that we are in unmute state and we're speaking. So, I mean, speaking to someone else. Okay. So be mindful of that. And generally, I keep on asking questions about the previous class, previous day's class, or some random question about something. So I would request you to speak up, you know, because um, if you don't speak up, it looks like it's a monologue. If only I keep on speaking, it doesn't really um, look much. Uh, I mean, doesn't really excite me or doesn't make the session interactive. That doesn't mean I get interrupted often, but whenever there is something I ask, please respond, and that would I will appreciate that. Um, so again, for those who have joined or who might not have joined the demo that was conducted on Saturday, here's a small glimpse of what we are going to cover in the course. Okay, so from the operating system perspective, we are going to cover the Linux operating system, various aspects within the Linux operating system, and from the Azure perspective, we are going to cover a lot of details, but these are very high level topics like how do you manage account management, resource groups, uh, identity and access management, virtual networks, virtual machines, storage, DNS, and Azure CLI. Okay. From the scripting automation perspective, we'll cover Linux shell scripting. Okay. And infrastructure as a code perspective, we are going to cover Terraform. From the source code management, we are going to cover Git and GitHub. How do we use Git? How do we configure GitHub and all these things? And software configuration management, Ansible. We are going to teach about. We're going to talk about Ansible and CI/CD. We are going to use Azure DevOps. Mind you, Azure and Azure DevOps are two different platforms. Okay, Azure is your infrastructure or public cloud where you have different services including virtual machines, virtual networks, and SQL servers, IoT, database, sorry, big data, including security services, monitoring services. Whereas Azure DevOps is a orchestration platform. Okay, that's why I'm very keen. I'm very particular about naming this course as DevOps with Azure and not Azure DevOps, because people might get confused that Azure DevOps is the actual tool we are learning. Azure DevOps is a separate application from your Azure cloud. So we're going to learn a bit about Azure DevOps and how to do CI/CD with Azure DevOps. Okay. Then from the containers
यार
perspective,
पर ये लोग कॉम्पिटेंट है ना, ऐसा है कि इनका असली है सारा कुछ, जाती भी है तो इनको पता है कि
yeah, that's what I was saying, right?
एनवायरमेंट कैसा है क्या नहीं है ना।
We need to be cognizant that we are speaking on
यहीं के पड़े हुए यहीं का ही सारा कुछ है, जो कहता है कि ये आईटी कर रहा है, इसके चार लोग होते
who's that person. Okay, thankfully he is muted. All right, and
Kiran Garu, we are not able to hear you. Are you speaking? Yeah, everyone please wait for a couple of, let me wait.
okay, sorry, I'm not sure. Something disconnected and it went back. It got disconnected. Yeah, I'm back now. Okay, so what I was saying was this is the curriculum, and apart from this, we will also cover a lot of theoretical aspects. Particularly in the first week, we'll talk about DNS, um, DNS, and the IP addresses. What is OSI model, and how do we create our own IP address range, and how do we understand the networking section? Okay, all these things we are going to talk about it, and what is three-tier architecture, n-tier architecture. All these things we are talking in the first week. Okay, so that's not in the curriculum, but that's pretty much part of our course. um, and then what should you have to join this course? Again, I talked to you in this demo, but those who have not joined the demo, very simple. You need a laptop or a desktop, preferably with 4 GB RAM and an i3 or a quad core. Even lesser configuration is also fine, because most of the things you're doing is it on cloud. And it's good to have system admin rights, because you will install some software, very minimalistic software, because most of the practices, like all these things I talked about, Ansible or Docker, you're going to practice it on a VM which is created on cloud. So yeah, subscriptions, you need Azure free tier subscription, but don't create it now. Don't create it till I tell you, because it's only valid for 30 days. So I would request you to wait till the time I talk about creating a Azure subscription. And you need a backup subscription after 1 month, because our course is going to go for more than 2 months. After 1 month, you have to create free tier subscription. Yes, you would need a credit card. For the backup account, you need to ask your friends to create from a different address, because Azure is capturing your IP addresses and not able, or maybe it's also capturing your MAC addresses, and it's not allowing you to create a second account for free. So you would need to ask your family or friends to create a secondary account for that. And you would need subscription for these free services: GitHub, Azure DevOps, and Docker Hub, and Freenom. You can create them today as well. Doesn't matter, or you can create them whenever we come to that topic. Okay, these are the softwares you need to install. Not immediately, but I'll tell you when to do that. But if you install also, it doesn't matter. Personally, as I said, I don't expect you to have any, you know, skills already, but if you have them, wonderful. If not, also that's pretty much fine. Okay. Uh, so please participate actively. That's my request. And again, do the practice, whatever things I ask you to read or do, please do post the class. Okay. Any questions before we proceed further?
No.
Okay. Again, as I said, the classes will be ideally from 7 a.m. to 8 a.m. IST. But for the first 10 days, I have some other engagement. So after maybe Feb 10th, or I'll tell you when this is going to happen. We are going to start from 7 a.m. to 8 a.m. Okay. I know folks in the US will be happy, or but folks in India might be like too early. But yeah, that's fine. We have to do that. All right. Then let's jump on to our first topic. Okay. So there is no presentation, but I would like to start the discussion with a very basic question. Okay. So let's say I'm accessing a web page like google.com or something. Okay. Uh, so what happens once you enter the URL, and from the time you receive you see the web page on your computer, on your laptop, or on your browser, whatever you want to call it as. Okay. So let's say you are a user, you're using your laptop, opened a browser, typed in google.com. Okay. So from the time you entered google.com, from the time the page opens up, not what happens after the page opens up, but you know, you opened your Chrome browser, you typed in google.com. Okay. What will happen next? Till the page is loaded on your browser. Again, one thing I would like to
It
say is
will
there
try
is
to
no,
start.
yeah, we are all learners here, so you don't worry about saying something incorrect or something. Most of you even don't know each other, so there's no problem. Just answer, even if even if you think it's not correct, that's fine. You'll learn eventually. Yeah. So what will happen?
It will buffer.
It will buffer. What does that mean?
It's try to fetch that information which we are trying to get it.
Okay, it will try to fetch the information, right? Then,
Or our request will hit.
First, it will go to DNS server,
mhm,
and then it will go to the load balancer
mhm,
in the DMG. Behind
mhm.
that, it will go to web server, and behind web server, there will be application server, and it will get the response from there.
Okay, so a lot of information here. So, Arshdeep, right?
Now, this is Manikumar.
Mani Kumar has given us a lot of information. He said there is a DNS. He said there is something called as DMZ, load balancer. A lot of information here. Okay. So, anyone else? Any other answers? Yeah, this is right. Okay, this is what happens, but we need to dig a little deep into this, because if you understand these things, only you would be able to troubleshoot going forward, or understand what happens. So what does DNS stand for? Anyone?
Domain naming service.
Domain name service. Okay. Yeah, we'll come to load balancer later. And DMZ is demilitarized zone. It is again another wartime terminology. We'll come to that also later. Okay, so you're right, Mani. So what happens when you type in google.com on your browser? So one thing you need to understand is, again, how does this communication happen? Through air or water, or what will happen when I type in google.com? Let's say on my mobile, which is connected to Wi-Fi. Where does the first request go to? I'm talking about the physical medium. So how does my mobile communicate with, let's say, the DNS server that Mani has talked about?
Through public internet.
Okay, what is this internet? I mean, what will happen, like in a physical way, when I type google.com on my browser, which is connected to Wi-Fi, where does the request go to?
ISP.
How does my ISP know? Like how does my mobile directly
Your
communicate
domain
with the
host.
ISP?
Your hosting services. It will try to
Hosting
reach
services.
to the hosting.
What
Yeah.
is that hosting service?
So wherever your domain is registered.
I don't have a domain. I'm just an end user. I'm typing google.com. Okay. So no, I'm talking about the basic thing. What happens? Forget about ISP, domain register, and all these things. When you type something, where does the first request go? So if your if your internet is not working, Wi-Fi is not working, what is the first thing you will check at home?
Router.
Router, right? So first point of contact is your router. So from your laptop or from your mobile device, how does this communication happen? Over air, right? Wi-Fi signal.
Yeah.
From your router, what happens next?
It
So
go
your
to
router is
switch.
connected with a cable, right? Yeah, if you have a
Yeah.
switch, it will go to switch. Or in your apartment complex, they might host a box. They call it as box, right? Which might have a switch or a hub, from which it will go to what would be the next hop? Someone has said something called as ISP. What is ISP?
Internet service provider.
Exactly, internet service provider, like your Airtel or Act broadband, uh, or
Geo.
Tata or Geo or whatever you have these days. Okay, so it will go to your ISP from. Okay, so let's say you typed google.com. The first thing your browser is going to search is its own cache. What is cache? Cache or cache or whatever
Cache
you call it
memory.
as. Cache is something that's like, storing your data temporarily for some time, like, which might be reusable. Okay, like your IP addresses for these things. Okay, and remember, your communication happens only, is our internet completely running on wireless or wired?
Wired.
Why?
How many of you agree it's wired?
So from ISP provider, it might be aware, but for ISP provider, it's non-wired, without wireless.
Okay, so but why do the ISP put a cable to your home, right? So it's wired, right?
Yeah. Uh,
This
From your laptop to Wi-Fi, it is wireless. From your router to the internet service provider,
wide.
it's wired.
from your
Wide.
internet service provider to, let's say, the domain naming services, it all happens through satellite, right? Your ISP will have a dish antenna which will send
Yes.
signal to satellite.
Satellite.
No, sir, we are not there yet. Everything happens through wired. Okay, internet communication predominantly works with wired networks only. You have under ocean cables, okay, running throughout your oceans, and these cables will get your data from your Netflix, YouTube, and everywhere. There is no satellite communication. There is this concept called as Starlink, which Elon Musk has brought it up, which will work through satellite communication. But right now, all the internet connectivity is through wired. Okay, the medium is wire. Okay, or the cables. What about your mobile data? If you are connected to mobile data, is the communication entirely happening through wireless?
Yes or no?
So where is my wired connected from my mobile data? In case of Wi-Fi, you know that there is a cable coming into your router which will go through your ISP. But in case of mobile data, what happens?
With the local
Connected to the
towers.
tower.
Okay, so till the tower it is wireless, from the tower it is again wired connection. Okay, so internet predominantly works on, the voice call might be working through satellite communication, through spectrum, but data is still predominantly wired. Okay, so that's why sometimes we have outages for many applications when there are accidents or some kind of incidents under ocean, some cables are cut and all that stuff, right? Okay, anyway, that's beyond the point, but just want to give you an idea. So first, your browser is going to search for this IP address. So computers at the basic level don't understand English or Telugu or any language. They understand numbers. Okay, so for my computer to understand to, so someone has said it will go to DNS server, then it will go to the load balancer. But for my computer to understand where the load balancer is, it needs to know something known as the address. In the case of computers, we call it as IP address. Okay, IP address is a format of numbers, okay, which computers can understand. So my browser might already have cached the IP address. Okay, if not, maybe this is a brand new laptop, or reinstalled everything from scratch, so this is a brand new laptop. Then the request goes to your, let's say, router. Some routers, or majority of the modern routers, have the capacity to cache your DNS names. So your router might serve a DNS name. So let's say it also doesn't have, it's a brand new router, you just brought it in or reset it. Then it goes to your internet service provider. Your internet service provider has something known as a domain name resolver. Okay. So as the name says, what it does is it converts your domain name into IP address and sends it back to your router, and maybe also your and then to your browser. Okay, let's say it's not google.com or some random website, so it also doesn't have the IP address. Then what does it do? So someone has said it will go to the DNS server, but which DNS server, right? So DNS is a very complex system. It has many layers. Okay, so if you open any browser, like for example any website, for instance, apps.diagram.net, we might not notice, but there is there is an invisible dot at every domain name. Google.com, there is a dot at, we will not see, it's not there, it's absent, but there is something called as a root server. Okay, that is represented by dot. Okay, so the request will go to something called as root servers, DNS root server. Okay, the first request, when your ISP is not able to resolve the IP address, it will go to DNS root server. Okay, this root server has information about all the top level domains. What are the top level domains? These are called as TLDs, or top level domains. For example, .com is a top level domain, .org is a top level domain, .co.uk, .co.in or .in, these days we have a lot of domain top level domains, right? We have .website, .tech, .me, .u, everything. I don't know if you have .u, but there is .me. What else? .tech, .xyz. Okay, you name it, and there are a lot of top level domains. Okay, each of them top level domains are the information about all these top level domains, and their servers are hosted in the root server. And let's say you're accessing google.com, and it will send you to .com server, so it will send you to the TLD. Okay, so it will send you to the TLD, top level domain. This top level domain, this could be like .com. Okay. So this has information about all the .com servers that are ever created. Okay, so let's say if you want to create a website called as google.com, you have Azure subscription, you can create multiple VMs and a load balancer and all this stuff. Can you directly create a website and call it as google.com?
No.
Why? Why not?
It's already registered.
Okay, so who registers this? Who will help you in registering this website? There is something called as a registrar. Okay, domain name
Yes.
registrar. Domain name registrar. Anyone knows of any examples?
GoDaddy.
GoDaddy,
GoDaddy
exactly.
is like
So GoDaddy is one of the examples
Google.
of domain name registrars. Google, yes, but I think they haven't kind of made it public. They use it only for their purpose. But we have GoDaddy, we have you know Anything else? Namecheap. AWS has its own domain name registration. You can buy AWS domains from AWS, Route 53. Freenom, which I talked about in the demo, which is a free service for, I mean, it will give you some random websites like .mg, .tk or all these things. But you can also buy your domain names from Freenom. I bought one from my Freenom. I had GoDaddy. GoDaddy is bad. Never use that. Namecheap, I think, is the best services among all these things. Route 53, yes, it has all the domain names, but these are costlier. Namecheap offers better rates. GoDaddy, bad service. Will not let you update name servers or anything. Okay. Freenom, good for all of you to create your domain names for free for 3 months. Okay. So let's say Google has its own registrar. So let's say the request is going to Google. Okay. So Google Register Services. So, or let's say some third party like Namecheap. Okay. So this person might have the IP address for the google.com. This register, not person, this router might have the IP address for the google.com. So what it does is it sends the information back to the .com top level domain. From the top level domain, it is again stored in DNS root server. From the DNS service, it will go all the way back to your ISP. In ISP also it is cached, and your router also it is cached, and your browser also it's cached. So next time, not only you, but if anyone else from your home is accessing the same domain name, it need not go through all these paths. It will directly, your router will be able to answer the query. It will say, okay, you're looking for google.com. Okay, here's the IP address, go there. Okay, it need not be browser, it could be web mobile app also. Mobile app also follows DNS in the backend. We don't see that, but there is DNS resolution in the backend happening. Okay, so finally, it goes all the way till the registrar. But in some cases, what happens is, okay, you might not maintain your IP address within the registrar. You might want to make, you might want to create your own domain DNS server. Okay, so then, oops, sorry. So then, what you do is you maintain your own DNS server, which will maintain the records of your, you might have multiple domain names like google.com, alphabet.com. All these things you want to maintain in a single location. You will maintain your DNS servers in a single location. You install the tool called as some OpenDNS or something, and here what you will do is you will have the records to maintain which IP address, which domain name should go to uh, which IP address. But how does your registrar know that this request has to be sent to this DNS servers? Okay, so there is a concept called as name servers. Okay, when you create a DNS zone, um, automatically these name servers are created. Okay, I mean, at least in cloud, these are created automatically. So these name servers have to be updated in your registrar. Here you're not updating the IP address directly, but your name server details. There could be 3 or 4 name servers. You'll update these details. So when the request comes here, your registrar says, like Namecheap maybe, it says, okay, I know that google.com was bought from me, but I don't have the IP address. But I can send you to a location where you can get the IP addresses. It will redirect to the name servers based on the entries we do here. Okay. So it's like, it says that I know a guy who knows things. Okay, so it will send to this guy or the DNS servers. He will answer the queries, and again the same thing happens. The caching will happen at various levels. That's why DNS is very fast. You don't even notice that these things are happening. Okay, and also DNS has something called as TTL. What is this? DNS has like 3-4 parameters. One of the parameters is IP address, like in a domain name like google.com, followed by IP address like 103.22.20 something. So if I do the ping, okay, so this is the IP address 142.150.188.66. Okay, let me do it from, this is a VM. Let me do it from my laptop. Ping command can be run from your Windows machine as well, from your command prompt. Yeah, see, I'm doing it from India. This VM is in US. It's giving me a different address. From India, it is giving from a different address because there is another service called as CDN. We'll talk about that later. Okay, but for your machine you will get one IP address, and it will also have something called as TTL, time to live. Time to live is till how much time this should be cached in the end system. Okay, Like you could set it up as 86,400 seconds. That's one day. So till one day, this address will not be refreshed. After the next day, your router is going to get the latest data from DNS, and DNS is going to get from DNS server. So it gets updated. Maybe google.com has changed its IP address. So there is a concept called as TTL, which we will talk about later. But this is what happens when you type in a domain name and it goes to the, it gets the IP address. Till this time, only one thing has happened, that is getting your IP address from your DNS server, or from the domain, from the website's DNS server, okay, or the registrar, wherever you're maintaining. Most of the major companies have their own DNS servers, so they're not going to simply maintain IP address inside the registrar. They're having to, they will have their own DNS server where they update these details. Okay, so till now only your IP address is there, is obtained. From now onwards, you have to do something else. From your browser has to go to that particular IP address. Okay, so remember, if you're accessing anything from internet, people might call it as cloud or whatever it is. At the end of the day, the request has to go to some kind of a computer that is hosting the application software, data, and all these things. Where is it hosted? We never know. Let's say this IP address belongs to a one physical machine, okay, where the google.com application is running. Maybe some kind of web application software like Apache or Nginx or Microsoft IIS, something is running. So that's where your request will go. Okay, so the request will go to a particular server where the software is running, and where Google has uploaded their images and HTML files and all the application code. Okay, so Google is a very, very big company, and Google is accessed by millions of users per second, right? So this system will handle a lot of traffic, right? Millions of requests per second, maybe. So maybe this machine has very high configuration, something like, 3 TB of RAM, and 4096 cores, almost 500 CPUs. Okay, generally, how many CPUs does your computer have? Cores, not CPUs. How many cores of
Minimum
CPU does your,
minimum 2.
sorry, minimum two dual core, right? If you talk about i3 these days, at least four i3 chips and above, you have at least 4 cores. Okay, and each of them has some frequency like 2.27 megahertz, sorry, gigahertz or something. So maybe this has very high clock speed also, like 3.9 gigahertz. Some very high-end processors, not like the Intel i7 or something, maybe some Xeon processors running at a very good speed and very highly, configured capacity and all these things. Okay, so your application also, so yeah, maybe this is where the IP address is taking you to. So this is where your software is running, and it is handling millions of requests per second. But when you search for something, till now you only got the google.com homepage. From here, let's say you searched for something like DNS. Okay, so it will give you some results. So where does it get its results from? Somewhere which is located in its database, correct? So that means you could host the database, or database is nothing but a software like MySQL server or a MariaDB server or a Microsoft MS SQL server. So this is a physical computer, just like your just like your laptop or desktop, but it becomes server only when it install when a certain software is installed. Okay, you could install both the web server and the database server. These are simple softwares only. So there is nothing like a web server in the market. You would just simply buy a server with so and so configuration. Whether you want to make it as a web server or a database server is up to you, based on the software you install on top of it. Let's say you decide to use the web server and the database, everything inside this, because it's a very powerful computer. Okay, but the challenge with databases is, even if they are not running at full capacity, they always hog 90% of the memory. Okay, that means your application, web server application, has only 10% RAM left to work. So you decide, no, I'm going to create a separate database server which is going to exclusively have only database software here. Okay, And it is also a risk when you put your database directly to the end users. Okay, so you decide you will create a database and which will run only database software. Maybe this is also very powerful like the previous one, 3 terabyte of RAM and 4096 cores, high-end cores and everything. Okay, and in the world of information technology, you have to remember one thing: systems are always prone to errors. Could be software, hardware, networking, whatever it is. Okay, so there is always a chance of failure. You have to be prepared for that. So let's say this one physical server is offline for a few minutes, meaning it shut down because of overheating or some other, or maybe the network cable simply disconnected. Yeah, most of the servers have redundant network connectivity. What do I mean by redundant network connectivity? More than one network provider can, more than one cable can be plugged in. Unlike our home connectivity, you cannot just rely on one. When you're maintaining a large application, you cannot rely on just one network provider. You will have more than one network provider. So you can connect multiple networks. But let's say the NIC card itself is failed. NIC card is the network interface card, or something else has failed. So this system is offline now. That means what is the impact for Google because of this?
No services.
No services for the entire world, maybe. Okay.
Yeah.
So what does Google do in this case? What do we have to do to mitigate this problem? Yes, you have a very high end system. Maybe it is cooled very well very often. There is a liquid cooling and everything is there. But what if, I mean, even then it could fail, or it could be a simple software failure and your system is still running, but the Apache or Nginx service is not running. So web server is unavailable. What will happen then? Still, the end users were not going to access anything. So how can you mitigate this problem?
Maintain one more web server.
Maintain one more web server. That is called as redundancy. Okay. Same server, same configuration. I mean, not in terms of hardware, but in terms of software and the operating system and the um, data, everything you maintain is almost same. So this need not be that powerful. Maybe this could be a 1.5 terabyte RAM and 2048 cores, right? But remember, I told you DNS is always like this: one domain name, one IP address. So if both these machines, there is an IP address for each machine. So if you have two entries, you cannot put two entries in your DNS records. So what will you do then? Which IP address will you give? If you give this IP address, and if this fails, this is not connected. Your DNS is always pointing to this one, so your request will always go to this one, even if it's down. Then what do we do? What we can do is, whenever there is an issue, you can fail over this. I mean, you can update the DNS name to the second machine. Okay, but the problem with this is it's not automatic failover. It is like manual failover, which means there is still downtime for your end users and there is manual intervention happening. So this is not really an ideal way. So what can be done? What can be done to mitigate this problem? So
Heartbeat
bring in,
confirmation.
yeah, you can do all that, but what you can do, another thing is, you can bring in a new server which will be like very very light machine, need not have 1.5 terabyte, maybe something with, let's say, 128 GB of RAM, and like, when I'm giving all large numbers, don't worry, we are not going to create that big machines, maybe 64 GB of RAM, something like that. Oh, sorry, 64 cores of CPU or something like that. So what this does is, it could have something like a reverse proxy or a web server, routing server like Nginx software. Its task is to do only one thing, which is receive the request and send the request to one of these two servers. Just like a receptionist at a bank, or a teller machine which gives you the token number to go to which counter, right? These days that is also automated, right? Earlier there used to be a receptionist who would say, okay, go to counter one or teller one in the banks. Nowadays it's also like an automated machine is giving us token, go to ticket number 7. How does that ticketing system works? It sees that there are four four different tellers, four different counters or cashiers. It will say first go to cashier 1, second to cashier 2, second 3. So that's round robin. So this could do in one of these methods. One thing is round robin. Every first request it will send to this server, second request it will send to this server. So which address you are going to upload in the DNS? This address. Okay. And the task it is performing is known as, what is it doing right now? Balancing the load between two or more machines. So what is it called as? It's called as a
Load
load
balancer.
balancer. Okay, load balancer could be a physical server like this, or these days we have you know, we have a specially designed system just like your router that you plug in at home, which will do the load balancing. These are highly available, meaning the chances of going down is very less, because when you talk about a physical server or a virtual machine, I mean, I'll come to what a virtual machine is. These are again running an operating system and a lot of other services and other stuff. But when it comes to a router also runs an operating system, mostly a Linux operating system, not router, a load balancer. But these are like very minimalistic. They do only have very minimalistic firmware. Um, so the chances of services going down and everything is little lesser. I mean, it could still go down, but mostly very highly available. Okay, so it could be a physical device you buy from F5. F5 is a company, or what else? Nginx also sells physical load balancers, I guess. So you can buy a physical load balancer and plug into your
Cisco.
networking. Cisco
Cisco
load
probably.
balancers, yes, yeah. So you have
Altian.
different kinds of what is that one?
Altian.
Sony firewall.
Okay, did not get that, but yeah, there are other vendors as well who sell the physical load balancers. Okay, right, but Uh, then what about the database? Database also might need redundancy. So you create different servers. Okay, and there might be also one kind of application load balancer or a virtual IP, because how do your web servers communicate with your database? Using IP address only. Remember, every communication between two systems happens through IP address, unless it's a Bluetooth connectivity or something, then it's a different case. So so this also need a like application load balancer for the two data. I know database specialists would say we would never do that. We would have a virtual IP and all that, but just giving an example. So you will have a database like this. Okay. But remember, two machines is not like very effective for an organization like Google. What if both of them go at the same time? There is a possibility. Google needs to maintain very high level of availability. So you have to go for 4 or 5 machines. But using physical machines is not the right solutions. So as I told you, uh, right now, like how cloud is like exploding from the last 6 7 years, early 2000s there was another concept which became very popular, which is called as virtualization. Okay, so just like how people are talking about cloud and DevOps these days, back in mid 2000s everyone was talking about only one thing: VMware. Learn VMware and your career is set and all that. That was the talk of the town back then, early 2000s and mid 2000s, because VMware has come. I mean, the virtualization software was there even before that, but VMware has marketed this and made it popular. So what this virtualization does is it takes one physical machine and on top of it, it can install multiple virtual machines. What is a virtual machine? It's one instance of an operating system. It's not its own computer, but using one physical machine, you can install multiple operating systems, each of them sharing some part of your base resources. What do I mean by that? Let's say, you have this physical machine with very good capacity of something like 1 TB of RAM and let's say 64 cores of CPU for CPUs. But if you don't have the virtualization software, at the most, what you can do is install only one OS. So every computer has something on the motherboard. What is it called as? What happens when you start a computer? it will any computer, even laptop or desktop, first it does something called as post power on self test. It will check if every component is accessible or not. Then the control is passed from your power to BIOS, or these days we call it as UEFI. Okay, in the BIOS, it's going to check whether there is a hard drive, and if there is it if it has a bootloader. So it will send the request to the bootloader. Okay, that's your hard drive. And typically one physical machine can have only one operating system, right? Anyone has dual booted laptops here?
Yes.
Okay, right. So one OS, and on top of it you can only run I mean, you can run multiple applications. You can run Apache, which is a web server. You can run PHP, which is an application server. You can run MySQL. You can run Redis. These are all simple softwares, just like your browsers. Just like how you can have both Firefox and Chrome, and also word processor. You can install all these applications on a single machine itself. But the modern IT infrastructure practices says that if you're running one OS, run only one application on top of it, because due to some thread locking or some issue with PHP, you don't want your web server to get affected. So let's say because of MySQL, uh, entire CPU is clogged. Now not only your database but all services are down, right? So that's single point of failure. That is what we call as single point of failure. So what is the recommendation is to run only one application per your OS. But when you think of running these on physical servers, even if you take smaller servers, they don't come with small capacity like 2 GB of RAM and 4 cores of CPU. They come with something like 32 GB RAM, 16 GB RAM and everything, right? Even mobile phones these days are not coming with 2 GB of RAM, right? But with the virtualization, what it does is, forget about the app layer, forget about the OS layer. On top of your BIOS, on your HDD or hard drive, you install a software called as hypervisor. Okay? What is this hypervisor? It could be like VMware ESXi or Microsoft Hyper-V, or there are open source tools like KVM and Zen. Okay, what these hypervisor tools do is they will let you install multiple operating systems as if each of them is a physical machine. So within this large machine of 1 GB, 1 TB of hard drive, you can create multiple virtual machines. Let's say this could be something like 32 GB and 8 cores. Okay, and you can install another. You can create another virtual machine. Maybe this is 256 GB of RAM and 32 cores of CPU, and then another machine which is running, let's say 8 GB, and maybe it is a database application, so it needs more RAM than CPU. Okay, so on and so forth. You can install any number of machines, or even as small machine as something like 1 GB of RAM and 1 core of CPU. Okay. So like this, you can create as many systems, and each of these systems can run its own operating system. Maybe this is running some operating system like Red Hat Enterprise Linux. Maybe this is running something like Windows Server 2019. This might be an Ubuntu system. Don't worry if you don't know about these operating systems. We're going to talk about some of these things. Maybe this is running something like CentOS. Okay, you could have as many uh, virtual machines as you need, but it has to, the total number of TB and cores cannot exceed the total this thing. Okay, that thing you have to be mindful. I'm not doing the exact math, but telling you the rough idea. Like this, one physical machine can be divided into multiple virtual machines, and each of them can host. It could act as a web server. It could be running something like Nginx. This could act as a MySQL server, or MS SQL, who will run MySQL on Windows. And Ubuntu, this could be acting as your PHP server. This could be acting as some Redis or some caching server, or maybe a DNS server. This could be acting as your maybe LDAP. Okay, this could be acting as some other service. Okay, uh, you know, maybe MongoDB. Okay, so like this, one physical machine can be divided into multiple virtual machines, and multiple operating systems. I mean, each virtual machine can have its own operating system, and on top of the operating system, you could install a separate service like a application like Nginx or Microsoft SQL or PHP or Python or whatever you want. Okay, so I'll tell you, if we all have jobs today and the internet has boomed so much, it's because of this hyper. I mean, one of the major factors is hypervisor. Of course, the invention of internet itself is a big factor, but hypervisor has really revolutionized the way applications are built, the way you can create multiple services within a single VM, single physical machine. Okay, so ideally, this is called as your host machine. These are called as your virtual machines. Okay, so now going back to the old picture, now these machines can be replaced with virtual machines. Okay, so again, um, as I told you, there are different kinds of hypervisor softwares. There are open source softwares like Zen and KVM. There are proprietary software like VMware ESXi, and there is Microsoft Hyper-V. Any other hypervisor you can think of? These are the popular ones. So now this is, instead of being a physical machine, this could be a virtual machine, meaning we don't care about the underlying operating system, underlying physical hardware. We're focused on these physical machine, virtual machines. Okay, so okay, just putting different logos here. Maybe the above ones are also running on Linux only. So from physical machines, we came to virtual machines. Okay, it has made life so easy and the management also so easy and cost effective. Okay, so you still might have to maintain different physical machines for high availability. What if physical machine itself goes down, right? So that is another concept. We'll talk about that later. But yeah, like this, you can create multiple virtual machines to run your applications on. Okay, so simplifying this picture, so there is this end user like you and me who has a laptop. Okay, who has a laptop, opens a browser and sends a request. So the request first goes to the DNS server. I'm not talking about the entire DNS server again because we have already discussed what that happens. So from the what happening from the DNS, you will get the IP address. The IP address is typically of the load balancer or a CDN. CDN is content delivery network. We'll talk about that later. So from here, it will go to the Google's data center. Obviously, the load balancer must be located in Google's data center, right? So it will go there, and the first request will go to the uh, load balancer. Just putting some Azure load balancer logo here. From the load balancer, it will go to a bunch of VMs. Similarly configured with similar software, similar version of OS, and everything is same. Okay. Go to the web layer first, one of the web servers. Okay, based on the routing configuration. The load balancer also has different load balancing algorithm like round robin, which means every first request is sent to first one, second to second, third to third, then the fourth one again to first one, and so on and so forth. Or um, there is another one called as availability. So if let's say for stateful applications like your banking websites where you will spend a lot of, you have to connect to the same VM throughout your transactions. Let's say you're going to Wikipedia, right? Wikipedia, let's say the first request you go to, first request, let's say, is sent to the first VM where you are served a static page, and from that page, let's say you clicked on another link. Let's say it will again come back to you, and the request is sent to the second VM. Does it make any difference for you? No, right? Because all the VMs have the same data. Maybe they're connected to something in the background with the databases. Okay, so this is your this is your web tier. A set of applications running similar set of software serving a certain purpose is known as your one tier, or here in this case we call it as web tier. Okay, this is your web tier. Then similarly, to run your database, to store your data, you might have something like a database tier also, okay, which might have a load balancer, because if these machines have to talk to it, they will talk to the load balancer, and load balancer will send it to one of these things. Okay, so this is your web tier. Okay, hope the font is clear enough. This is the DB tier. Most of the simple applications can run with these two tiers. Okay, this kind of you know setup is known as your three tier: your client, which is your browser or some other app, and the web tier, which will serve the front end pages, and the DB tier. These things are known as three-tier architecture. I mean, this kind of setup is not these things. This type of architecture is known as three-tier architecture. But think about Google website, right? When you go to google.com, what you search and what I search is completely different. Is it right or not? What you search and what I search will not completely different, but it will be customized to as per your user behavior. That means based on your logged in details, based on your previous history, sorry, based on your search history, based on what kind of things are you interested in, and based on what you're looking on Amazon, Google will steal all this information and customize your web pages. So that means there is some kind of business processing, some logic happening in the background. Okay, so not only your web and DB, there could be another tier known as your business logic, simply logical processing, or what we call in terms of IT is a application tier, like which will do the basic computation, like okay, uh, what is this user, what did he do last night, what songs he was listening on Amazon, everything is captured by your Google, which is bad. So you have this application tier which is performing the logical processing. Okay, not only Google, many of the websites might have a application tier here in between. It could be running some Java code, some Python code, or Golang, or whatever it is. Okay, so this, I mean, sometimes without app tier also it could be called as three tier, but typically this is how your three tier architecture looks like. Okay, but modern applications are not only about some front end page and some business logic and database. There are a lot more aspects to it. For instance, the instance search, right? The minute I type domain, this is going to give me some results. Okay, and it could be, you know, some other application, some other service which is giving me these results. Maybe some NoSQL kind of service called as MongoDB or something is giving it. Or real-time analytics, right? You know, these days computers want to know real-time what you're doing, and based on that give the results, right? Like your location processing and all that other stuff. So there could be multiple tiers, not only just the app, web, and DB. There could be a caching layer, because let's say your, right, Google has this, Google can predict what users are searching, or at least it can tell what is being searched, correct? Meaning, let's say some assassination attempt happens on a big leader. Okay, some assassination attempt happens on a big leader, so everyone will search for that particular user, that particular search string, right? For example, let's say an assassination attempt has happened on some Canadian prime minister. He's in the news, so why not talk about him? So what happens, everyone searches for the same result globally. So your the request will first go to the web tier, and again, to get the information about that one, this DB has to be contacted, right? But you know that a lot of the requests are going to the same page again and again. So if there is a capability for the web tier to cache some information without going all the way here, maybe you could launch something like a caching tier. Okay, so caching servers are placed close to your web servers. I mean, they will go directly here. They will immediately answer the query instead of this going to the database and querying for all the results. Okay, so there might be a caching tier, there might be real-time analytics, there might be so many other tiers, meaning different services running different kind of services. So this kind of service is called as n-tier architecture, where you have more than 3 tiers. But folks, nowadays we moved from the monolithic applications to move to what we call as microservices. So microservices architecture is totally different from this 3-tier and n-tier paradigm. It's like breaking your every application into multiple small services running in different sections. Okay, so this could be one of the examples. So there could be multiple interactions. Okay, multiple applications running in multiple things. Okay, so I'll try to find out a better image tomorrow. These are some of the examples how your microservice. There are a lot of services for a single application to work, and all of these are interconnected, and there is service discovery and a lot of other stuff. Okay, but I just wanted you to understand how the DNS resolution works and how the what is a 3-tier application and an n-tier application and virtualization part. Okay, so that's what we discussed today. So when we are working on cloud today, there is this virtualization process which is happening in the background. We are not doing it. Microsoft, for example, when you're using Azure, Microsoft has created the software that is required to create VM whenever you require a VM. So you go to the Azure portal and make a request for a VM. Okay, you click on few things and create a VM. So what's happening in the background is this process, but this is almost all of these things is abstracted away from us, meaning we don't see what's happening in these layers. You'll only get the VM directly with the required operating system and you start using it. Okay, and of course you cannot install any operating system on the VMs. They come pre-installed with some pre-designed operating systems. Like you could get Microsoft SQL, you can install Windows Server 2019. Yeah, you could get something like CentOS and Red Hat, and there are different operating. Of course, you could also use your own version of operating system, your own machine image. You can import from your on-premise environment, but Microsoft comes with a preloaded operating systems for which with which you can launch your virtual machines. Okay, so all these things you don't have to worry about it. Okay, the hypervisor level and all these things you don't have to worry about it. If you know them, very good. You can manage both a data center as well as a cloud subscription as well. But you will directly get the virtual machine. So we will be dealing with the virtual machine level as well only. Okay, and even our load balancers, we are going to use Azure services. Okay, so we are going to see all these things, right? So that's it for today. So today, as I said, we talked about DNS resolution, we talked about virtualization, we talked about the 3-tier and n-tier architecture and a little bit of microservices. Okay, so particularly after containers, everything is moving to microservices paradigm. Okay, so today's task is very simple. There is one beautiful video about this DNS, whatever I explained, but in a much graphical and better way, how DNS works. The channel name itself is how DNS works. Uh, I think this is the one. No, not this one. Oh. I think this is the one. Hey, that was a beautiful video. Channel name was also how DNS works or something like that. Mm, Yeah, this one. Uh, I mean, this is not the original publisher, I guess, but yeah, this is the video I'm talking about. Please take a look at this one. Okay, and also read about 3-tier, N-tier architecture, domain name, registrar. Oh, by the way, just 2 minutes, we'll wind up. Someone has said that we cannot we cannot create a google.com website. It has to be registered. So you will buy from Namecheap or something, right? We have different registrars. Okay, so Namecheap, GoDaddy, Freenom, Route 53, Amazon Route 53. So if I buy from Namecheap, how does my Amazon knows that this is already sold out and they cannot be sold? Obviously, there should be some central authority, right? And who will decide what can be the top level domains, right? So there are two organizations which will deal with both uh, these IP addresses as well as the domain names. One is IANA, Internet Assigned Numbers Authority, and ICANN is Internet Corporation for Assigned Names and Numbers, I guess. I forgot. I keep forgetting this. ICANN. These are both closely work together. These are like non-profit organizations. Okay. So the Internet Corporation for Assigned Names and Numbers, multi-stakeholder group and non-profit organization for coordinating the maintenance and procedures of several databases related to the namespaces and numerical spaces of the internet. Okay, so that the IP addresses are always unique, and the domain names are always unique. Okay, it is concerned with the DNS. Okay, it was initially began by some company in I think some government organization within the US, and they have now it's a non-profit organization. Okay, similarly you have IANA, they both work together. Okay, it will work with the IP addresses. And tomorrow we'll talk about IP addresses and what is a public I mean different types of different types of IP addresses, and how to find our IP addresses and all this stuff. So tomorrow and the day after also mostly focused on networking section. Okay, so we'll discuss various IP addresses and not various various types of IP addresses. Okay, if you have any questions, I'm here till the next 5 minutes. Otherwise, we'll wind up for today.
Hey Kiran, I just want to know, like, will you be sending like the recording for this session? Because I missed first 10-15 minutes.
Okay, yeah, the recordings will be sent to you by my colleagues. They will
Okay.
contact you through WhatsApp. There might be a Google Drive which will be shared with you. And
Okay, man. Thank you.
any other questions?
Yeah, Kiran, I have one question actually. So we talked about monolithic paradigm, right? And wherein you rely on web server, application server, and database server. So when it comes to microservices, will it use any server in the background, or it is serverless completely? Hello, can you hear me?
Yeah, yeah, I can hear you. So your question is, when you talk about microservices or any other kind of architecture where we don't see the VMs directly, do they have a server in the background? Okay, so there is one popular meme in the internet
Yes.
which says, there is a t-shirt also, there is nothing called as cloud, it is someone else's computer. Okay, so you might call it as serverless, you might call it as container, you might call whatever it is. Somewhere someplace there should be a physical computer which is doing this transaction for you. Okay,
Yes,
it
I
could
agree. Yeah.
you could call it as platform as a service, software as a service. It only means how much it is hiding before. I mean, see, if you're ordering some food from somewhere, it has to have some kind of cooking that is done somewhere, right? Unless it's a
Correct, correct.
plant-based,
Yeah.
right? That's a different thing. But
No, no,
yeah,
I'm not talking about the server as a machine or virtual machine. I'm talking about
mm.
web server or application server concept. Whether that kind of, see, whether your code will be deployed in web server and application server or not,
ah,
or
see, there
microservices
is nothing.
directly deal with database without
See,
web layer.
there is no concept called as a web server, right? You have a VM, and on top of a VM, you install an operating system. It could be a Linux-based operating system. It could be a Unix operating system. So based on what software you install on top of it, it becomes a web server and a database server. Okay. So this is a role. Okay. This VM is playing the role as a web server. And you can install another
Yeah,
VM, and on top of the VM, you install something like MySQL. That becomes a database server. Okay. Or maybe if
correct,
you
correct. Yeah,
uninstall MySQL and install Apache, it becomes a web server. This Apache could be running on the entire VM, or there is a concept called as containers. Just like how virtualization helps you divide one physical machine into multiple um, VMs, there is a concept called as containers, where within one OS you can run multiple containers, right? Using Docker or some other tools,
yeah.
you can run
Hmm.
Apache. You can run Apache and also MySQL on the same VM. Okay, and there is total isolation of each other. You can isolate each other from uh, so just like how virtualization has changed the physical hardware, at the operating system level, containers have changed that. So as you asked, this Apache, for example, for your web server software, you're using Apache. So this Apache need not be running on top of the OS. It might be running on top of your containers. Okay, so there is one layer between your operating system and your application. Now you have something called as a container. Okay, but this container can run only on some kind of a virtual machine, okay, or a physical machine. You can run containers on your laptop as well. But the advantage of with containers is these are isolation. This is isolation at the level of operating system. Within one operating system, now you can run multiple services like web service using Apache or Nginx or some other thing, MySQL in another container, and each of them will be separately, completely isolated. You could set up limits on how much CPU this container can use, how much CPU that container can use, so on and so forth. Okay, yeah, but at the end of the day, it is running on a VM. Again, the VM is running on some kind of physical hardware that must be there. Okay,
Okay.
yeah. So, and just because you're saying it's a microservice doesn't mean it has to run on a container only. Containers make it easy to run on microservices. You could run them on VMs as well. Okay. How your
Got it.
application is architected is important. Like earlier, one up the entire processing is done by one single monolithic code, which is doing multiple transactions. Now what they're doing is they're breaking this into multiple small things. Okay, for authentication, one piece of service, two pieces of services are running in different containers. For your fetching bank account details, it might be running multiple different. You take UPI for instance. Okay, so UPI might be running a
Yeah,
lot of backend API calls. Okay. Okay. Any other questions regarding the course or anything? Don't ask me the fees. You'll be contacted about the fees. All right, then. If you do not have any questions, will I'll take your leave and we will connect tomorrow and discuss more about
thank
IT
you, sir.
architecture.
Bye bye.
Thank you. Thank you, everyone.
Thank you.